Hi guys, welcome back to my channel. You know, I've already started shape of the molecule and I have discussed almost all the molecule. I found some of the molecule I left which I want to discuss today. That molecule normally came in the past paper. So let's discuss a few of the molecule and hopefully that's my last video on the shape of the molecule. Look at that. Uh, that's one question. Like, what is the shape and bond angle of BF4 minus BF4 minus boron trifluoride? Let's start with the boron trifluoride, which is trigonal planar. Boron has three valence electron, but here one of the fluorine give a pair of electron to boron. Look at that one, boron trifluoride, and that's the overall charge, guys. This is the overall charge. This charge, a negative charge, is not present on the boron, and we discussed like Vesper theory, valence, Ves, electron pair, repulsion, VES, repulsion theory. According to that theory, any negative charge act as a lone pair, and if that negative charge present on the central atom, that negative charge definitely influence bond angle and the shape of the molecule. Valence shell electron, Vesper theory, valence shell electron repulsion theory. V valence VES Vesper theory, valence electron shell repulsion, shell electron pair. Look at that, valence shell electron pair repulsion theory. According to that theory, any negative charge which act as a lone pair, if that negative charge or a lone pair present on the central atom, that will definitely uh, create a disturbance or distraction in the bond angle and the shape of the molecule, or that will definitely affect the bond angle and the shape of the molecule. But here the negative charge is not present on the central atom. This negative charge is the overall charge. So this BF4 minus is closely resembles to methane molecule structurally, not in the chemical functionally, not in the chemical properties and the physical properties, only similar to methane molecule. Look, BF4 minus is closely related to structurally methane molecule. Central atom is carbon in case of methane molecule. So central atom like carbon having four bonded pair of electron and no lone pair. I'm keep on telling you guys, lone pair, there's no lone pair, and the central atom has no lone pair. This negative charge is not present on the boron. So look at that. It's a tetrahedral shape. What's the bond angle and the shape of the molecule? Bond angle BA 109.5, and the shape, any guesses? Tetrahedral. Shape of the molecule, It's TD, tetrahedral. Okay, now can I rub the board, guys? Now look at that. We will do some past paper question on the shape of the molecule and the bond angle of some questions. Now look at that. Predict the shape and bond angles. Predict the shape and bond angle. Predict the shape and bond angles of the following. H2S A, H2S, AlCl3, AlCl3, Si, F4, and last one is PH3. Central atom is from group 6, sulfur, having 2 lone pair of electron and 2 bonded pair of electron. So what's the shape and bond angle? When it has 2 bonded pair of electron and 2 lone pair, bent V shape, bent V, non-linear, 104.5. AlCl3, aluminium is the central atom. Aluminium has 3 electron in the outer shell, 3 valence electron, and it can make 3 bond. AlCl3, 3 bonds. So it has 3 bonded pair of electron and no lone pair. Trigonal, planar. And what's the bond angle? 120 degree. So in case of SiF4, central atom is from group 4. Silicon has 4 electron in the outermost shell. So 4 bonded pair of electron and no lone pair. Silicon tetrafluoride, 4 bonded pair of electron and no lone pair. Central atom is from group 4, 4 bonded pair of electron and no lone pair. So what's the shape? Closely related to methane molecule, tetrahedral. What's the bond angle? 109.5. Any guesses for PH3? PH3 is similar to ammonia molecule. Phosphorus, central atom is the phosphorus, having 3 bonded pair of electron and 1 lone pair. 3 bonded pair of electron, hydrogen, PH3 is phosphine, hydrogen and 1 lone pair. 3 bonded pair of electron and 1 lone pair. Shape of the molecule is trigonal, pyramidal. Bond angle, any guesses? From 109.5, 4 bonded pair of electron, no lone pair. When a molecule has 1 lone pair, so we have to subtract 2.5 bond angle. So it will be 107. Okay, we will do one more question. Can I rub the board? Okay, one more question. Predict the shape and bond angle of the following. Predict the shape and bond angle of the following. Predict the shape. Predict the shape and bond angle of the following. A. Hydrogen cyanide HCl. B. NH2, a negative charge. NH4C, ammonium ion, NH4 plus. D. H3O plus. E. Ammonium, hydronium, ethene, C2H4. F. CH3, this is ethanol, so you have to work out here for central atom. Now for me it's in here. CH3, ethanol, methanol or ethanol, no worries. So you have to work out here shape and bond angle. PO4 3 minus overall. Yep. Now we will do one by one. HCl, hydrogen cyanide. There is a triple bond between carbon and nitrogen. How the molecule looks like to you guys? I told you ignore pi bond, ignore double bond. So the molecule looks like linear, and the bond angle is 180. That's a tricky. NH2 minus. Look, nitrogen, in case of ammonia, it formed three bond with three bonded pair of electron, but it formed only two bond pair, and ammonia has already one lone pair. In case of ammonia, central atom, that nitrogen has one lone pair and one more negative charge. Negative charge acts as a lone pair. So it has two lone pair and two bonded pair, just like a water molecule. So what's the shape? Bent, non-linear, 104.5. Most of the students, they are getting confused with this molecule. So it looks like structurally it is similar to water molecule. Now some more. Ammonium, I have already discussed ammonium ion, nitrogen. In case of ammonium ion, nitrogen make four bonded pair of electron and no lone pair. Look at nitrogen has four bonded pair of electron and no lone pair. The positive charge is, first of all, it's overall, and it is not on the central atom. Even though the positive charge is present on the central atom, it won't causes any deviation in the bond angle or any change in the shape of the molecule. Okay, so four bonded pair of electron, no lone pair. Shape is tetrahedral. Bond angle 109.5. Now hydronium, hydrogen, what oxygen has two lone pair, but one of its lone pair donated to H plus ion. So one lone pair, three bond pair, and the overall charge is positive. It is similar to the shape of the hydronium ion is closely related to ammonia. I'm talking about the shape, guys. So three bonded pair of electron and one lone pair. Trigonal, trigonal, pyramidal, and a bond angle is 107. Now ethene molecule, ethene, shape and bond angle of ethene. Ethene has one double bond, carbon-carbon double bond. Now ethene, ethene has carbon-carbon double bond. Look, it's a flat molecule, planar molecule. Each carbon has three bonded pair of electron. Pi bond will not affect the bond angle and shape. So carbon has three bonded pair of electron and no lone pair, which is closely similar to BF3. So what's the shape? Trigonal planar, trigonal planar, and bond angle 120 degree. Now in case of ethanal, it's an aldehyde, guys. We have to work out here only for central atom carbon. I'm not talking about this carbon. This carbon is like a methane, four bonded pair of electron and no lone pair, so tetrahedral. This is tetrahedral. I'm talking about this. Let me draw again. I am talking about, look at that, ethanal aldehyde. So I gather all these questions from different past paper, HVA, OCR, Edexcel. Now, ethanal, CH3, carbon has double bond with oxygen and one single bond. Look, that carbon, we're talking about that carbon. One bonded pair of electron. This is also bonded pair of electron. This is also bonded pair of electron. Ignore the pi bond. Don't worry about the pi bond. So central atom is the carbon having three bonded pair of electron and no lone pair, similar to that one. Trigonal, planar, 120 degree. Trigonal, planar. Look at that one. Okay. Now, very tricky, guys. I'm putting some asterisks on it because it's a tricky molecule. Most of the student, they say linear. Now, look at the central atom. I always tell you, focus on the central atom. So central atom is from group 6, having two lone pair and two bonded pair. Structurally, this methanol is similar to water molecule. So look at here. Oxygen has two lone pair and two bond pair. It's very close to the water molecule, which is a bent molecule, two lone pair and two bond pair. This is also like a water molecule, so bent, non-linear, 104.5. When I rub the board, I accidentally rub one of my molecule, like phosphate ion, come from phosphoric acid. That's the last molecule. Okay, did you get it? Yeah. Now the last one, phosphate ion. Phosphate ion come from phosphoric acid. Phosphoric acid, what is the chemical formula of phosphoric acid? H3PO4. H3PO4. So central atom has phosphorus with a double bond with oxygen, O hydrogen, OH and OH. Phosphoric acid is an acid acid has the ability to give away the proton. So it can give away 3 proton. It's a tribasic acid. Look at that. When it gives away 1 proton, it has 1 negative charge. So in case of phosphate ion, H3, in case of phosphate ion, PO4 minus. In case of phosphate ion, PO4 3 minus. It gives all of 3 hydrogen. Look at that. Phosphate, P double bond O a negative charge, O a negative charge, O a negative charge. There will be no negative charge on the central atom, guys. Central atom is phosphorus, having 4 bonded pair of electron. Even though if you ignore the pi bond, 1, 2, 3, 4, 4 bonded pair of electron and a no lone pair. So it's structurally similar to methane molecule. 4 bonded pair of electron, no lone pair. So what's the shape? What's the shape of methane molecule? Why I'm keep on telling you go back and check the parent molecule. That's the parent molecule. What's the parent molecule? Methane. So methane, we know the structure, we know the shape and a bond angle. Tetrahedral, and bond angle 109.5. So I want to stop here. Thanks for watching my video. I will come back soon.